Hello and welcome everyone. So today we are starting a series where we will cover all the chapter-wise previous year question from CUET entrance, that is from 2020 to 2025. So today we'll start from Physical Geology and Geomorphology. So the first question is given here: the oceanic crust is not older than. So oceanic crust, the present day oceanic crust, they start to form when Pangea breaks. Before that, all the oceanic crust, they are destroyed to form a supercontinent, that is Pangea. So the breaking of the Pangea will be the during the first breaking of the Pangea, which form the Tethys Sea, that will be the oldest oceanic crust. So the breaking of Pangea is around 200 to 180 million year is considered between 200 to 180 million year. So we'll see which age will coincide with this. So Permian it ends at 251 million years. Then Triassic it is from, you can say, 251 to 201 million years. Then your Cambrian, it is started from 538 or 541 million year. Then Cretaceous it is 66 million year. So among these options, your Triassic will be the correct one. So the oceanic crust is not older than Triassic, because before that all the oceanic crust are destroyed. So next question: in the geomagnetic scale, the magnetic epoch prior to the Brunels. So these magnetic epoch, they represent a dominant, normal, or you can say reverse polarity during different time. In the present time, we have a normal polarity, and that is called as your Brunel's epoch. So this evidence you will find in mid-oceanic reefs, where the strips of magnetic, you can say strips of magnetic evidences are preserved on the both side of the mid-oceanic reef symmetrically. So this is our present day time where we'll get Brunels. Then before Brunels, there is a reverse polarity which is called as your Matsuyama. Then there is normal polarity, that is called as your Gauss. Then there is reverse polarity, that is called as your Gilbert. So question here asks: in geomagnetic scale, the magnetic epoch prior to the Brunels, that means before to the Brunels, it will be Matsuyama. So answer will be Matsuyama. And you remember this sequence: Brunels is the youngest and Gilbert is the oldest. And from younger to older, it is Brunels, Matsuyama, Gauss, Gilbert. Then Brunels is normal, then reverse, normal, reverse. Alternatively, you will remember. So let's come to another question, that is from Volcano. This is the finest pyroclastic material. So what is a pyroclastic material? So pyroclastic material is the solid product that form during a volcanic event. So solid products are called pyroclastic material, and liquid products are called lava. Pyroclastic material. All the solid product during volcanism are called as pyroclastic material. So it is asked which is the finest pyroclastic material. So pyroclastic material we have volcanic block, bomb, then cinder, lapilli, then we have ash. So block bomb, they are of same size, it is between greater than 32 mm. So block is angular in shape and bomb is rounded in shape. Cinder, lapilli, they are between 4 to 32 mm, where cinder is vesicular, lapilli is non-vesicular. Then ash, it is 4 to 0.25 mm, and there is also fine ash, where is less than 0.25 mm size. So that means among these four, ash is the smallest. So answer will be ash. Next come to another question where we have discussed it in the previous question: most appropriate example of geomagnetic reversal. So geomagnetic reversal, with time the magnetism polarity changes. So that is best recorded at the mid-oceanic reefs. On the both side of the Miocene ridge, symmetrically you will get magnetic strip that preserve the polarity, which will be Miocene ridge. Then comes to next question, the boundary between crust and mantle. So Earth is divided into three layers on the basis of composition. So one is your crust, which from 0 to 35 or 33 kilometer you can say. Then mantle, it is 35 to 2900 kilometer. Then your core, so it is 6371 kilometer. So these are three main compositional layer. In between crust and mantle we have Mohr-Bisick discontinuity. In between mantle and core we have Gutenberg discontinuity. So these two discontinuities are called as your primary discontinuity. It is between major layer. So you have another your discontinuity present in between crust, which is called as the Conrad discontinuity. It's between CL and Sima. So that is called as your secondary discontinuity. We also get another discontinuity here between outer core and inner core, that is called as your Angelman's or Lehman's discontinuity. It is at a depth of 5150 km. This is also a secondary discontinuity. That means we have two types of discontinuity. One is primary, that between major compositional layer, and another is your secondary, that is in between compositional layer or within the compositional layer. So here answer will be, it is given in between crust and mantle, it will be Mohr-Bisick discontinuity. Next question comes to the Miocene ridge present in the Bay of Bengal. So this is our Indian Ocean, this is your Bay of Bengal part. So this ridge, it present almost parallel to the 90-degree longitude. So that's why this is called as your 90 east ridge. So the Miocene present in the Bay of Bengal, it is called as your 90 east ridge. So this is a ridge that produced because oceanic intraplate volcanism. So there is a hotspot here called as your Kerguelen hotspot. Kerguelen hotspot. During the passage of Indian plate over Kerguelen hotspot, they produce this ridge because any plate that present over a hotspot that produce volcanism, and if the volcanism is you can say if the plate motion is slow, then the ridge will produce an island like your Hawaii type of thing, which produce intra oceanic plate volcanism. 90 ridge is also that type of ridge that produce when Indian plate passes over the Kerguelen hotspot. That also produces Rasmol trap, that because of Kerguelen hotspot, Rasmol CLA trap. So answer will be 90 east ridge. You can see here also, this is your 90 east ridge. So next come to another question, which one of the following rocks is generally found in the island arc? So island arc, it is produced because of composite plate condition. So you can take here, this is your continental plate, sorry, this is your oceanic plate, this is continental plate. The oceanic plate is basaltic. When volcanism occur, it assimilate with the continental plate or metal from the continental plate, and the magma is generated, it is as basic, but while it is passing through the continental plate, it become intermediate, that is produce an andesitic composition. So that's why the answer will be andesite, because granite is characteristic of your continental crust only. Then pegmatite, it is a rock that produced because of magma. When magma highly reached to its H2O content, that produce pegmatite, which is characterized by very coarse grain. Dolomite, it is a sedimented rock. So this island arc, that may confuse you, because island arc term, it is generally can be used in place of volcanic arc or continental arc, but in specific condition the island arc is used when there is a convergence between oceanic and oceanic plate. But there is no other option here, so you have to consider that island arc as continental arc or volcanic arc. So answer will be, that's why, andesite, intermediate composition. Next comes to the smallest plate on the earth. So that it is a data question, so I have to remember that is when the Fuca plate, it is the smallest plate that present here in North America plate. You can say on the Pacific plate, sorry. It converges with the North America plate. So this is your Juan de Fuca plate. It diverges from the Pacific here, which produce Juan de Fuca ridge. That is a transform plate here, and this Juan de Fuca plate that converges with the North America plate and produce a mountain range that is called as Cascade Mountain Range. So smallest is your Juan de Fuca plate. Then comes to the total length of the mid-oceanic ridge. So mid-oceanic ridge, it is the longest ridge system in the world. So approximately the total length of the mid-oceanic ridge that is present in the earth or world, that is approximately 65,000 kilometers. That's why the approximate answer will be 60,000. Then what is the half-life of radiocarbon? So you know radiocarbon, it is carbon 14, has a half-life of 5730 years. So the half-life of carbon 14 is 5730 years. That's why it is used to basically used to determine the age of the recent sample or younger sample. Then comes to the dripstones growing from the top to bottom of the limestone caves. So so this is the floor of the cave. This is roof of the cave. Okay, your precipitated deposition that grow from the floor, that is called as a stalagmite, and that is grow from the roof, it is called as a stalactite. And when they will join together, they produce a column. When the stalactite and stalagmite join together. So here if the question asks the dripstone that form from the top to bottom. So this is your top side, this is bottom side. Top to bottom means it will be stalactite. And spelotherm, it has collectively define all the, you can say, precipitation deposition within the cave. The concretion, siliceous sinter, then carbonate deposition, all are collectively called as your spelotherm. You can see a diagram here also, where this is your stalagmite, this is a stalactite from the roof, from the stalagmite from the floor, then column when they will intersect with each other or join with each other. So come to the next question, where is sand dune in which the top of the crescent faces. So they have two types of dune, which is crescent in shape. One is your parabolic dune, another is your Barkan dune. So this is your, you can say, top of the crescent face. Your wind is flowing in this direction. This is the top of the crescent face. This is the wind flowing direction. So this is your Barkan. This is your parabolic. Now the question asks the top of the crescent faces the wind direction. So this is the top of the crescent, you can say. Here it opposite to the wind direction, and this is towards the wind direction. The parabolic dune. So the answer will be here your parabolic dune. So these are the four major types of dune. One is Barchan dune, another parabolic dune, then transverse, then longitudinal. Between these four types of dune, the wind direction is perpendicular to the dune in case of Barchan, parabolic, and transverse. Okay, crescent shape. Then your longitudinal dune, it is a bidirectional dune produced by bidirectional flow or wind direction, which has equal slope on both sides. So this is a Barchan dune. You can see it is crescent shape, where this is your convex side, this is your concave side. This you can say upwind, this is downwind. So upwind will be convex, downwind will be concave, which is opposite in case of parabolic tube. And always remember, this is a slip face, which will be the steeper one. It is always towards the downwind side. So here parabolic case also, this is slip face, which is always towards the downwind side. This is a transverse dune that form perpendicular to the wind direction. There is another dune which is called as a star shaped dune, which is produced when there is variable wind flowing direction or fluctuating wind flowing direction. That is also called as a star dune or riots. This comes to isolated rock or knob masses in the desert region. The isolated rock knob masses in the desert region, what we'll call it? Column, it is in your underground water condition, where in limestone cave we'll find column where stalactite and stalagmite might will meet. Then Inselberg. So Inselberg is the isolated rock or knob masses in the desert or semi-arid region. It produced during peniplanation stage, where any landform that undergoes one cycle of erosion. At the last stage, you will get these peneplains. On the peneplains, or you can say peneplain, that is called as Inselberg, also called as monad rocks. Then mesa and butte, they are produced by, you can say, tectonic activity or by differential erosion. Mesa is butte generally found in plateau region, where because of erosion you will get isolated mass with flat top, that is mesa, and mesa is further eroded to produce butte, which has a rounded top. So your answer will be Inselberg. Isolated masses in the desert region, that is in arid region, you'll get Inselberg. Now, which of the following geological agent that produce Roches Montagnais? So Roches Montagnais, it is produced by glacial action or by valley glacier action. When glacial passes through any asymmetrical rock, so it eroded it into this type of structure, which is called as a Roches Montagnais, which is also called as sheep back rock. So this is the glacial movement direction. So this is your Roches Montagnais, where this side is Stoss side, this side is lee side. The Stoss side is gentle, lee side is steeper. So always remember, in case of glacier, the Stoss side or the gentle side, not that is Stoss side. Whether there is a gentle side, it will produce abrasion, and if it is a steeper side, it will produce flocking. This thing is opposite to crag and tail, where the Stoss side is steeper and lee side is gentle. So answer will be glacier. Then comes to in marine depositional feature, a beach or beach of sand or gravel that connects the island to the mainland or to another island is known as. So these are called as a tombalu. See here. So in ocean, in submarine condition, you will find deposition called as a bar, speed, and tombalu. These are main depositional feature in the coastal region. So bar is produced by a longshore current, where there is current flowing parallel to the ocean coast, or you can say beach, that is called as your longshore current. Because of longshore current, you will get deposition, small sand, small reeds type of deposition, that is bar, when that deposition formed above the sea water, that is called as your barrier. Then there is tombolo. Suppose there is an island here, so any deposition or connecting bar, you can say, that connects the island to the mainland, that is called as tombolo. So how tombolo deposition occur? Because when sea water will come, so it will first bombard with the island. Then in the lee side of the island, the energy decreases, and they will produce a bar type of deposition, that is called as your tombolo. So tombolo, it is a connecting bar that connects the island with the mainland. Then speed is another bar where the coastal region, you will find any bend in the coastal region, you will find a deposition that connected to mainland at one end and open to the sea at other end, that is called as your spits. So speed produced where there is a bend in the coastal region. Tombolo formed because of presence of island, and barrier, your bar produced because of longshore current. Speed also produced by longshore current. So next come to 2021 question, that the geological term used for an episode of mountain building. So mountain building, it is called as your erosion. So during your continent collision or during convergence, you'll get squeezed sediments that produce mountains, that is called as your orogeny. It is called as your orogeny. Any mountain that produced because of horizontal movement. And erosion, another term that is used when there is vertical movement of the lithosphere or crust. So horizontal movement, it is called as your orogeny, vertical movement is called as your erosion. So mountain building process, that is called as your orogeny because of horizontal compression of the plates. Then craton, it is tectonically stable area where there is no tectonic activity since 1.2 billion years. Then terrace, it is from your river terrace, you can say, is produced because of tectonic upliftment. Then shield, it is the exposed part of the crater. So answer will be erosion. Next, the ring of fire. So we know the ring of fire, it is a chain of volcano that produced around the convergent plate margin, where the Pacific plate converges in the American plate and Eurasian plate part. So the ring of fire refers to the location of earthquake and volcano along the rim of the Pacific Ocean. You can see this is the Pacific Ocean along the margin of the Pacific Ocean. Starting from this Peru Chile trench, you will get continuous ring of volcano up to this much, which is called as your ring of fire. So it is along the rim of the Pacific Ocean. On the Hawaiian Island, you will get volcano, but those are intra-plate volcano, that is within the Pacific plate. And mid North Atlantic slip, you will get volcano, but that is divergent plate mountain, it is not produce a ring. And surrounding the Indian Ocean, you will get volcano, but that is not producing a ring. So that means answer will be the Pacific Ocean, along the rim of the Pacific Ocean. Then if a beaker of seawater were left to evaporate and dry, the mineral left present in the container would most likely to. So because seawater evaporate, they need deposition, that will be precipitation deposition. So we'll analyze the option first. Biotite and quartz. Biotite will never occur, never produced by your precipitation. So that means biotite quartz will be incorrect. Well, biotite is a metamorphic rock produced by metamorphic process. Then comes to gypsum and halite. So gypsum and halite, these are sulfate and chloride that can be produced by precipitation of seawater. So answer will be gypsum and halite. Fluoride galena produced from the seawater but by hydrothermal process. So it will not correct. Calcite may produce, but chalcopyrite, it is produced by hydrothermal process. Answer will be gypsum and halite. So during evaporation of the sea, The first thing that will precipitate, that is carbonate. That is carbonate. You can take calcite and aragonite. Then next thing, your sulfate, gypsum and anhydrite. Then your chloride, that is your halite and salt. Then you'll get your KCl, sylvite, or magnesium chloride, that is carneliite. So this is the sequence. First, carbonate will precipitate because they have very, you can say, less solubility. So then sulfate, then chloride. When 90% above water will evaporate, then we will find the deposition of or precipitation of chloride. So answer will be here gypsum and halite, and remember this thing, it is very important. Then the longest topographic feature on the earth. So obviously it is interconnected oceanic ridge system. It is the longest that we have discussed. Himalayan mountain range, it is approximately 2400 kilometer. Alps 1200 approximately. Ganga river system 2500 kilometer. And intercontinental oceanic ridge system, it is, we have discussed, 65,000 kilometer. So this will be the longest. Then which of the following soil will have the highest cation exchange capacity? So what is cation exchange capacity, or CEC? It is the capacity of, can say, soil or clay to either hold cations or exchange with the cations, because clay and your that organic content, humus, they have more negative charges. So the CEC, can say, CEC depends on clay content and humus or organic content. Organic content. Any rock more clay content, they have more CEC, or organic or humus content more CEC. So clay, it has higher surface area, it contains more negative charge, like you will take multimolite, kaolinite, illite type of mineral. Organic content, they contain humus, they also have more OH minus ion, they have high, you can say, CEC capacity. So between your humus and clay, or organic matter and clay, organic matter has high CEC. So which of the following is will have the highest exchange cation exchange capacity? So any soil with more clay content and more humus content will have more CEC. A soil with high silt and clay. Just remember this sequence. On the basis of CEC, humus has greater than clay, greater than silt, greater than sand. So sand, as you can see, 0 CEC, doesn't have any negative charge cations. The soil with high clay and humus content, this will be the answer. High silt clay content, they have more CEC, but they doesn't have more CEC than this high clay and humus content, because mostly depends upon the clay and organic matter. So the soil has more humus and more clay, they have more CEC. Low clay, it will be not the option. Sand does not contribute, so CEC does have 0 CEC. So the suitable answer will be a soil with high clay and humus content. And which of the following planet has the highest number of known natural satellites? So we have here Mars, which have 2 satellites, that is your Phobos and Deimos. Venus doesn't have any satellite. Uranus has 27, Neptune has 14. So highest will be Uranus. So answer will be Uranus. Next, arrange of elements: hydrogen, helium, iron, hydrogen, oxygen, silicon in increasing order their abundance. So the most abundant element in the earth in the solar system is your hydrogen. Hydrogen is the most abundant. Then after hydrogen we have helium. Okay. Then oxygen. In between Fe and Si, Fe will be more abundant than Si. The answer will be C. So you can see here in this diagram, hydrogen is the highest, then helium, then you'll get oxygen, then you'll get iron, then silicon. So this is the abundance of element within the earth crust, within the solar system. Let's come to sea mounts and the island chains in the oceans are formed due to. So what is sea mount and island chains? So these are island chains are interconnecting chains that produce when any plate that passes over a hotspot. You can take the example of 90 studies, that is also intraplate volcanism, and you can take the example of Hawaii, that also intraplate oceanic volcanism. So when there is a hotspot here and a plate is passing through over the hotspot, then you will find volcanism on the hotspot. As the plate will pass over it, gradually you will find a chain of island. So if the volcanic island that is submerged within the sea, that is not exposed to the surface of the sea, that is called as a sea mount. If erosion flatten the top of the sea mount, that is called as a GOET. And if it exposed to the above the sea surface, that is called as a volcanic island. So this will be intraplate volcanic activity origin from the hotspot, where it produced within the oceanic plate. So generally, there is volcanic island produced, which is above the sea surface. Then after gradual erosion, they submerged to produce sea mount and goets. So you can see the example here. So there is a hotspot here. This is fixed. This plate is moving over the hotspot. Before this point was on this hotspot. Okay. Then before that, so this will be the oldest. Then gradually you will find younger. Now this is Hawaii region, that is below the hotspot. So as the plate will move more, then this thing will shift to this region and another island will produce. So that's how it produce interconnecting chain, or you can say interconnecting chains of islands. Then age of the ocean floors are ranging from. So they have discussed earlier, the ocean floor does not older than 200 million years. So the answer will be 0 to 200 million years, that I have already discussed. Then comes to isostatic model proposed by Aries. So Aries proposed an isostatic model which state that the continental crust or the crustal part has same density but unequal thickness. So all the crustal part, whether it is continent or ocean, they all have same density. The thickness will be different. So first option is given, considered as mountain have higher density than oceanic crust. It will be incorrect because all the crustal part has same density. Consider the mountain have lower density than the oceanic crust. It is also incorrect. Consider the mountains have same density as the oceanic crust. So this will be correct. It does not consider density. It is incorrect because according to Aries hypothesis, continental crust have same density, or crustal part has same density. In case of Pratt's hypothesis, you will find different density at different part. So that means in Pratt's hypothesis, density varies in between different part of the crust. Also the thickness varies. But in case of Aries, it is same. Then most abundant element in the earth crust by volume. We all know the most abundant element in the earth crust is oxygen. So Most abundant is oxygen, it is 46%, then silicon it is 28%, then you will get aluminum 8% by volume. It is also the most abundant metal in the earth crust, that is aluminum. Then you will get iron, magnesium, calcium and others. So in sequence, oxygen is the most abundant, then silicon, then aluminum, then iron, then others. Then the failed arm of a continental rift. Suppose we have a triple junction here, which consists of your ridge and ridge system. Now see, if these two are moving, these two boundaries are moving, but this is not moving. So this is called as your failed rift. Failed rift. It does not move with time or break with time. That is your East African rift, which is a failed continental rift that occur in upper triple junction in the African plate. So that is called as your Olacogens. Okay, this is called as your Olacogens, the failed rift of a triple junction. So host, it is you can say a normal fault structure. Hotspot, it is where volcanic activity occur. Island chain because of hotspot. So answer will be Olacogens. This you can see here. These two rifts are moving, but this is not moving. Then the ozone layer found in which level of the atmosphere? So ozone layer, it is found in stratosphere, that helps to absorb all the UV rays that come from the sun. So we have this four layer, that is troposphere, stratosphere, mesosphere, thermosphere. You can see here. There is the layers of atmosphere. So see, these are the four layers of the atmosphere: troposphere, stratosphere, mesosphere, thermosphere. Then see, in troposphere there is a decrease in temperature, that is called as a temperature inversion. As you go more altitude, the temperature will gradually decrease, and at the boundary between stratosphere and troposphere, the temperature is constant, that is called as your tropopause. And in stratosphere, you will get your ozone layer. In stratosphere, again temperature increases, then remain constant in between mesosphere and stratosphere, which is called as stratopause. Then again temperature decreases in between thermosphere and mesosphere, there is constant temperature, that is called mesopause. Then in thermosphere, again temperature increases. So first decreases, then increases, then decreases, then increases. So these are different layers. So it is very helpful in our CUET entrance, because some of the questions that comes from the atmospheric part. Then come to thermohaline circulation. So thermohaline circulation means, thermo means there is temperature, haline means salinity. So thermohaline circulation basically depend on the density. So indirectly the density affected by salinity and temperature. More saline, more denser, and less temperature, more denser. So the thermohaline circulation is also called as your conveyor belt of ocean. It is also called as your conveyor belt of ocean, which is driven by density, and the density it is depend upon the salinity and temperature. So your question asks, the thermohaline circulation in the ocean generally does not depend upon. So it generally does not depend upon the magnetic field. So answer will be magnetic field. Let's come to one of the erosional landforms developed due to glacier. So all these landforms are produced by glacier, but it is asked about erosional landforms. So Sark, it is an erosional landform that produced because of your abrasion action and blocking action of valley glacier, where a valley that eroded to an armchair-like structure or amphitheater basin-like structure. You also get a lake at the base of the Sark, that is called as your Tarn Lake. It's called as your Tarn Lake. So this is an erosional feature. This will be the answer. Moraine escarp caves, they are also produced by glacier action, but they all are depositional feature. So moraine, it is valley glacier deposition, which is considered as a till, unstratified, unsorted. Then esker, it is a glaciofluvial deposition. It is a sinusoidal type of deposition where the esker is stratified because it is glaciofluvial. Then came, it is found in outwards plain. It is a hill type of structure that also, as it is glaciofluvial, it is also stratified and sorted. So these three are depositional. This is your erosional feature. So answer will be SARC. Then triple junctions are the points. So triple junction means where three plates or three lithospheric plate will meet. So these are this answer will be correct. So the three plates, they can be continental plate, they can be oceanic plate. So that's why this will be incorrect. This will be incorrect. This will be incorrect. So answer will be three plates made. You can take the example of Afar triple junction. You take the example of Galapagos triple junction. There are many triple junction which consist of three tectonic plates, but the boundary are different. So they maybe consist of all three divergent boundary, all three convergent, all three transform, or they can be considered of mixed of different types of boundary. And between your triple junction, the most stable is your Rees boundary, where the triple junction consists of three diverging plate boundary. Then which of the following is the process of formation of new ocean basin according to Wilson cycle? So what is a Wilson cycle? So Wilson cycle refers to the opening and closing of the ocean basin. In the beginning of the, we can say, Wilson cycle, there will be rifting. There will be rifting of the continent. So when any continent will rift or break, so it will produce a small sea within, or it will produce a small sea in between the two rifted continental plate. So you can take the example of East African rift, where the Wilson cycle begins. So first there will be rifting. Then after rifting, sea will or water body will intrude into the rift. That will produce a sea. The example of that is your Red Sea. Then this sea will gradually enlarge by because of diverging of the plates. Then that will produce an ocean. That the example of Atlantic Ocean. Then that ocean gradually destroy by converging. That is the example of Pacific plate, and the last stage where the ocean will completely destroyed and will produce a mountain. That the example of Himalaya. So which are the following process on new ocean basin by Wilson cycle? That is your Red Sea. So this you can say different stages of Wilson cycle. First is your embryonic stage, that is called as your stage A, where there will be rifting because of upliftment of the plate by hotspot, you can say, or mantle plume. So uplift, there will be breaking of the continent, which is called as your initial stage or embryonic stage of the Wilson cycle. The example is your East African rift system. Then juvenile stage, there will be diverging or spreading of the continent, which will produce a narrow sea in between the two rifted continents. Then with further divergence, then comes the mature stage where the sea will enlarge to an ocean, that is called as your Atlantic Ocean. Atlantic Ocean also that produced by the divergence of American plate and African plate. So initially American plate and African plate were together. Then the rifting will start. Rifting will start. Then they will start to diverge. When the rifting will start, they produce a ocean that is called as your Proto-Atlantic Ocean. Then now in present day it is enlarged to your Atlantic Ocean by divergence. So this is your mature stage. That means Atlantic Ocean, it is in your mature stage. Then declining stage, where the oceanic plate will now converge and gradually it start to destroy. It's a Pacific Ocean where it is converged in both your Eurasian plate side and your American plate side, where the plate gradually destroyed. That is your declining stage. Then turbulent stage, where gradually it will converge. There will be collision between two continents, and uh, remnant of the sea will find, that is your Mediterranean Sea, which is remnant of the Tethys Sea, because Tethys Sea is completely destroyed by convergence. Then your suturing stage, that is the last stage, where the two content will converge and suture themselves. There will be no subduction because two content plates, they never there will be no subduction because the two content plates are same density and they produce a mountain range. The example is your Himalayan mountain. So the present day, the embryonic stage, your East African plate. It will later come to this juvenile, mature, decline, terminal, and suturing stage. And the Red Sea, it is in your juvenile stage. Atlantic Ocean is mature stage. The next stage of Atlantic will be, it will converge and start to destroy. So this indicates the Wilson cycle, where a ocean basin will open and close. So that means ocean basin start to form during rifting, then that destroyed by your convergence. That's why all the oceanic crust that produced before your Pangea time, they all destroyed by this process, and your new oceanic crust that is present till date, they start to produce from the breaking of the Pangea, that is Laurasia and Gondwana. In between them, you will find Tethys Sea. That is the first oceanic crust. That's why they are not older than 200 million years. Next comes to, what are the three components of the stream power equation. So what is the stream power equation? That is your stream power equal to rho q g s. So rho is the density of the water, q is the discharge, g is the acceleration due to gravity, s is the slope. So here is more stream discharge, channel slope, and water density. These three components will use to calculate the stream power. So answer will be D. Then karst topography, it is an irregularly eroded topography where you will find all the underground water feature. So it is produced by groundwater erosion, mainly groundwater. It doesn't erode by mechanical process, mostly it is eroded by your chemical process. So groundwater, it is very slowly moves through the interconnected pore space. That's why it doesn't have any mechanical power. So only produce features by chemical action. So that chemical action basically occur in carbonate region, and any carbonate region that is eroded by underground water will be called as your karst topography or karst erosion. So answer will be groundwater erosion. The layer of the earth that is broken into 7 large and many small rigid plates, what we will call lithospheric plates, or you can say tectonic plates. So that is your lithosphere. So lithosphere is our plates which broken into 7 large plates and many smaller rigid plates. It floats on asthenosphere, which is from 0 to 100 kilometer is your lithosphere, and 100 to 660 kilometer is your asthenosphere. So lithosphere floats on asthenosphere. Lithosphere is brittle and asthenosphere is ductile. Then comes to another question. A mountain experiences a constant rate of uplift of 1.5 meter per year. So upliftment, it is 1.5 meters. At the same time, the mountain also changed by erosion at a rate of 2.6 meter per 1000 year. Height also decreases at a rate of 2.6 meter per 1000 year, increases 1.5. So 1.5 minus 2.6 1.1 minus. So that means there is a decrease of the mountain height. So 1.5 is uplifting, 2.6 it is eroded. So that means there is a minus 1.1 decrease in height, minus 1.1 kilometer per thousand year decrease in height. So that's how overall there will be decrease, the height of the mountain will decrease. Then comes to Lonar Lake. So Lonar Lake, it is situated in Maharashtra. So it is produced by meteoritic impact. So because of some meteorite, they fall on the earth, they produce a depression, that is produce a lake, it's called as a Lonar Lake. Then hydrolysis or solution. So there are two terms may confused with, one is hydration and another is hydrolysis. Hydration means just addition of water. Hydrolysis means water will break down into H plus and OH minus ion. They will exchange ion with other compound, like here you can take the example of salt. So hydrolysis is the exchange reaction between water ions and salt ions, because there will be during hydrolysis water will break down into H plus and OH minus ion. It will exchange ion with the salt, that is Na plus and Cl minus. So answer will be exchange reaction between water ions and salt ions. Let's come to which one of the following geomorphological feature has the highest groundwater potential. First thing, Inselberg, it is consists of a crystalline rock. This is a residual hill that we have discussed in the previous questions. So Inselberg is consists of basically crystalline rock or igneous rock or metamorphic rock. So that's why they doesn't have the groundwater potential. Piedmont zone has groundwater potential, but it is less than valley fills. So valley fills, where any valley that filled with mixed sediments from coastal to finer, so they have more. They are very loose, you can say. Mostly, you can take the example of buried valley, where glacial deposition or glacial sediments fills the valley, or any more glacial fields or valley fields, they are very loose. So that's why they have most higher, or you can say highest groundwater potential among these. So answer will be D. Then comes to snowflakes. So snowflakes, they are ice crystal resulting from sublimation. This is incorrect, because sublimation is a process where from gaseous matter to you'll find solid matter directly. So ice crystal doesn't form that way; it produces from liquid. Then ice crystal fuse together. If they fuse together, they produce ice mass or knee form, or ultimately they produce a glacier. Then small lumps of ice, does not define snowflakes. There is frozen raindrops, because snowflakes fall as snowfall, so they are very you can say porous. So answer will be frozen raindrops. So frozen raindrops are called as your snowflakes, which gradually with compaction converted to glacier above the snow line. Let's come to this question. Which one of the following statement is false for landslide? So landslide, it is a mass shifting process where mass or sediments, you can say dry sediments or sediments filled or mixed with water, they flow downward with the help of gravity. That occur because of slope failure. When any your sediments are present on the slope of the mountain, then they are held on the slope by two forces. One is gravity, one is friction. When weight of this thing will increase or friction will decrease, then it will move downward by the influence of gravity. That is called as your landslide or mass wasting. So landslide can be caused by natural and man-made factors. So the landslide can produce because of your heavy rainfall, when the sediments are, you can say, saturated with water. When sediments saturated with water, its weight increases. If your weight increases, then gravitational force will increase, then it will pull the sediments downward. That one cause, that is called as slope failure. Then man-made factor, you can take the example of well being blasting or road work or anything that produce your seismic waves or vibration to the ground, they can cause landslide. So they can trigger landslide. So this is correct. Landslide due to slope failure. So because of this imbalance in forces, that is called as your slope failure, where gravity increases or gravitational force increases. So this is also correct. Then rockfall is not a type of landslide. So this is incorrect. So rockfall, it is, you can say, free fall of rock around an or along a cliff, you can say, that is called as a fall. So basically rockfalls are very dry and they are very, you can say their speed is very high. So rockfall, it considered as a landslide or mass wasting process. Then vegetation helps to checking landslide. It is also correct, because vegetation, the plant root, the root of the plant, they held the soil, so they prevent for the sliding. So that's why vegetation always helps to check the landslide. So this is correct. So the answer here, it is given which statement is false. So this statement is false. Rockfall is not a type of landslide. So answer will be C. Then move to this double match question. First thing, lahar. Lahar is also a mass wasting product, but here it is related to fast moving volcanic mud, mostly pyroclastic material or volcanic ash material mixed with water. They flow down the hill. So that is called as your lahar. Pyroclast we discussed, that is fragments of hot rocks that coming out from a volcanic vent. So this is called as your pyroclastic material, that is solid product. Then fluorine, it is a very toxic volcanic gases. Then volcanic stream, that is called phreatic eruption. That is any volcanic eruption that charged with uh, volatile matter, or you can say water, that is called as a phreatic eruption. Or you can say any volcanic eruption that come in contact with the groundwater, then erupt the surface, that is called as a phreatic eruption. So basically phreatic eruption, volcanic eruption charged with water or volcanic steam. So answer will be A will be your third, B fourth, C I D second. So A will be third, B fourth. So on option B. Option B will be the answer. The Mariana Trench is the deepest part of the world's ocean. So Mariana Trench, it is produced by convergence of Pacific plates. So it is occur in the Pacific Ocean. It occur in the Pacific Ocean. It is a convergent plate boundary where the Challenger Deep is the most deepest part of the ocean. That is approximately 10,000 kilometer. Which are the following does not represent a plate boundary? So oceanic ridges, it is produced during divergence of oceanic plates. You can take the example of East Pacific ridge. Then abyssal plain, it is the deep sea plain. So it does not indicate any plate boundary. So this will be the answer. Then oceanic trenches, it is between convergent plate boundary. Then transform fault, it is also indicates a plate boundaries. So abyssal plain here, it is called as your deep sea plains, which does not indicate any plate boundary. Then which are the following hotspot located in Indian Ocean region? So these type of questions are frequently will find in CUET exam, where you will have to determine whether the hotspot is present in the oceanic plate or continental plate or in any other specific lithospheric plate. So which one of the following hotspot is located in the Indian Ocean region? So these are the list of hotspots that are present in worldwide. So we'll see Galapagos hotspots. It is present in Pacific Ocean. This is your Galapagos hotspot. This is your North America, South America. This is North America, and this is your This part is your Pacific plate. This we can say ring of fire. So Galapagos hotspot. This is Easter hotspot. Then your McDonald hotspot, Hawaii hotspot. They all present in the Pacific plate. So here it is given in Indian Ocean region. Then your Tasmania hotspot. So the Tasmania hotspot that present near Australia, it is towards the Pacific. Then comes to Kerguelen hotspot that we have discussed it in 90 degrees condition. The Kerguelen hotspot that present in the Indian Ocean. So Kerguelen Reunion also present in Indian Ocean. Then Afar junction, it is important. It is present in your continental plate, African plate. So these Kerguelen, Reunion, Hawaii, they are present in the oceanic plate. This is an Afar is an continental hotspot. So just remember these hotspots and their regions. So the answer will be that Kerguelen. Then the internal structure of the earth has been identified on the basis of. So internal structure, so from surface to the core, have a radius of average radius of 6371 kilometers. Okay. So seismological evidence, because we cannot dig to the core because of increasing geothermal gradient and pressure. So that's why we take indirect evidence by seismic activity. We produce seismic wave that enter into in the subsurface region of Earth. Then according to the change in velocity of the seismic wave, we can determine the layers of the Earth, because seismic wave, it is an elastic wave that changes with change in density, rock composition, like this. So seismological evidence, from that we identified the layers of the Earth. Ground penetrating radar imagery, it is used to mineralogical or your ore exploration. Drilling, it cannot be possible to the center of the earth. Deep vertical electrical sounding, it is also used to determine ore exploration. So that is one your seismological evidence that helps to determine the layers of the earth. Next question, your movement and collision of plate accounts for the most of the earthquake and the volcano. So mostly the volcanic activity, it is caused by plate movement. So the major volcanic activity, you can say, it occur at the plate boundary. So in divergent plate boundary, you will get shallow focus earthquake. In convergent plate boundary, you will get all type of earthquake from deep to shallow focus. So movement and collision of plates, that produces earthquake. And also volcanoes, there also are, you can say, confined to the plate boundaries. Except your hotspot volcano, all other volcanoes are confined to the plate boundary. You can take the example of ring of fire. Then plate movement is caused by convection of Earth's internal heat. So plate motion, how it is occur? It is because of magmatic convection at the mantle region, where the hotter magma gradually rises upward. Then while it is rising, it loses heat. Then the temperature will decrease. Then it become more denser. Then it will gradually move downward. So this process is called as your convection, and because of the convection, the plate above it gradually slides or moves. So this assertion that it is indicate key movement of plates, and the reason it indicates movement of plate by convection. So both A and R are true, and R is the correct explanation of A. So answer will be A. So next comes to this double match question, where different soil horizon and their characteristic we have to match. So let's see one figure. So these are different soil layers where you'll get O, A, E, B, C, R. So O horizon, it is humus, the top horizon. Then A, topsoil. E horizon, which is elevation layer, it is otherwise called as your B horizon, it's subsoil, and C horizon, regoliths, the broken fragments, bedrocks. Then are your bedrocks. So these are different layers of the earth, the layers of the soil. So the A horizon here, it is the uppermost horizon, that lacking O horizon composed of mineral matter with finely divided organic matter. So you will find roots and burrows, that is the top A horizon. So A will be second, first. Then B horizon, it is elevation layer. It is enriched in your clay, oxides, hydroxide, all these things, magnesium, aluminum. So this will be third layer. Then C, it is partially weathered, lowest or partially weathered horizon. That possible parent material include bedrock and sediments. There is a C layer. Then K, it is mostly another sub layer which consists of potassium rich. So it will be your partially weathered horizon cemented with calcium carbonate hard pans. This is your K layer. So answer will be B. Answer will be B. Next comes to given statement. Statement 1 and 2 is given, so we have to choose which is correct or which is wrong. Weathered rock is fractured or chemically altered rock that has not been mobilized by hill slope and bioturbuation process. So basically, the weathering means simple disintegration. After disintegration, by another process erosion, it displaced from one place to another. So if you are simple considering weathering means it is either chemical or mechanical breakdown. So there will be fracture or chemically altered rock that not be mobilized. So that is called either weathered rock. So it is correct. Then saprolite different from weathered rock in degree of alteration. Saprolite, it is highly chemically altered rock, you can say. So it is from the weathered rock, it is also an weathered rock, but in terms of degree of alteration, it is more altered than a simple weathered rock. So both of the statement will be correct. Both statement 1 and 2 are correct. Next one, to how do alluvial river responds to base level changes? So what is a base level? This is considered sea level. Sea level. So sea level always considered as base level. So river can incise their valley up to base level. So this is the last limit of incision. So below base level, river cannot erode. That is also called as a base level of erosion. So on that basis, which statement will be correct? Will say aggradation occur when base level rises. Aggradation is a process of deposition within the river valley, and degradation is a process where there will be incision. So first we have to understand at what condition there will be aggradation and what condition there will be degradation. So if the sea level, if the base level rise, that means the sea level rise. If the sea level rise, then base level will rise, and in that case, there will be deposition, there will be aggradation. If the sea level will rise, because if the sea level will rise, then the river should match with the sea level, so it start to deposit. So the base level will rise. If the sea level will fall, then they find more room for incision, then there will be degradation. There will be degradation. So sea level rise will produce aggradation, sea level fall will produce degradation. Let's see. First statement, aggradation occurs when base level rises. Aggradation occurs when base level rises. Incision occurs when base level drops. This is the correct statement. Because incision, it is indicating degradation. So when sea level fall, base level will fall. There will be incision or down cutting. When base level rises, or you can say sea level rises, there will be deposition, that is called aggradation. So incision occur on base level rises, aggradation occur on base level drops. It is incorrect. Increase in sediment load when base level rises, decrease in sediment load when base level drops. Increase in sediment load when base level rises. When base level rises, the gradient will decrease. That decrease the sediment load. So that's why it is incorrect. Decrease in sediment load when base level rises, decrease in sediment load when base level falls. Both cannot be decreased at once, so it will be incorrect. So answer will be aggradation occur when base level rise and incision occur when base level drops. Then maximum size of grain that a particular flow can entrain is called as. So there are two things we have considered: capacity, competency. So capacity, it is the size of it is the volume of sediments it can take. Competency, it is the size. It is the size and it is the volume. So the answer will be your the maximum size. It will be competency of the flow. Then which of the following condition is characteristic of braided river? So braided river, what is a braided river? In the river channel, the river will bifurcate and again reunite. That is called as braided river. So the bifurcation that occur because of deposition of braided bar within the river channel. So how the braided bar will deposited? What are the conditions? So first, non-cohesive banks. If there is a non-cohesive banks, that means the bank metal is loose. There is no cohesion between them. Then there will be more erosion at the bank. You can say ki it is a condition for braided river formation, non-cohesive bank, or you can take erosive bank. So that will supply more sediments. Then bed load dominated in the sediment transportation. If there will be more bed load, so there will be if more bed load condition, the river cannot carry that much of sediment, so it can give deposition at the mid part of the river valley. Then frequent fluctuation of flow. So if there is frequent change in energy, there is more higher energy or higher velocity, lower velocity, or there is frequent change in velocity, then there will be deposition. So that deposition is called as a braided bar. Because of the braided bar, the channel will bifurcate. So these are the main cause of the braided river formation. So answer will be all of the above. Okay. So non-cohesive bank, bed load, frequent fluctuation of flow, they all contribute to formation of a braided river. So this is very important. Then which of the following cases will you get a deeper basin? Fast, slow, spreading. There are two conditions. So how a fast spreading and slow spreading condition will affect the ocean basin depth? See, in a slow spreading diverging plate bound or slow spreading ridge, there will be less supply of magma. There will be less magma supply. So because of less magma supply, there will be less formation of new oceanic crust, and because of slow spreading, they you can say become cooler and denser earlier than a faster spreading rate. So they get more time to become cooler and denser. Because of denser, they subsidence more. So that's why a slow spreading your center or slow spreading ridge will produce a deeper basin than a faster spreading ridge. The faster spreading ridge has more magma production, slower spreading ridge has less magma production. And slower spreading magma get more time to become cooler and denser and get more subsidence. So answer will be slow spreading ridge produce deeper basin. Next question, your assertion and reason. The inner core is solid iron alloy. So you know the inner core is solid. Why it is solid? Even though inner core is hotter than the outer core, it is solid because it deeper and subjected to very high pressure. So because of high pressure, inner core is solid. We all know. So because pressure increases the melting temperature. So both A and R true, and R is the correct explanation of A. Then which is the most abundant element in the earth crust? Already discussed, it is oxygen. This is very important. First oxygen, then silicon, then aluminum, then iron. Then the seismic moment M. It is defined by this formula M equal to G. It is your shear modulus. A is the fault rupture, area of the fault rupture, and AW means displacement across the fault. So they all are directly proportional to seismic moment. So seismic moment, it defines the amount of energy released during earthquake. So they all directly proportional to seismic moment. That is, more shear strength, more energy will release. More rupture, more energy will release. More displacement, more energy will release. So this is your correct answer, A. Then a river crossing an active thrust and maintaining the concavity of its longitudinal profile. So this is the condition of antecedent, you can say. Suppose a river is flowing in a region where the region it is uplifting, but still river maintain its course. That is, the amount of upliftment it is equal to the amount of erosion. The amount the river valley will uplift, again that is equilibrated by erosion. So that is a condition where upliftment is occurring and again downcutting is occurring. That is a condition which is called as a negative feedback system. It's called as your negative feedback system. So next question, it is on the basis of your cycle of erosion model. The two models, one is your Davis model, another is your Penck model. So let's see statement 1. In his model of landscape of evolution, that is cycle of erosion, Davis regarded landscape as evolving through a progressive sequence of stages, each exhibiting characteristic landforms. So according to Davis, he divided into three parts. One is your youth, mature, then old stage. According to different stage, different landform will produce and different energy condition will be determined. But according to Penck model, landscape evolution was a continuous adjustment between force and resistance. So according to Penck, there is no particular stages like youth, mature or old. He argued that the landscape that have undergone long period of denudation, there will be mutual adjustment between lithological controls and prevailing surface processes. That means if there is erosion, then there will be upliftment. So that will be tectonic adjustment. So according to Penck model. So both the statement indicating their respective models. So statement 1 and 2 both are correct. So this is up to your 2022. Then in the next video we'll cover or solve the 2023 to 25 question. And in this series we'll continue all other chapter-wise PYQ also, like your mineralogy in the then very important for is your atmospheric science and oceanography part. Then petrology, all part will be covered gradually. So this is for today. So in the next part we'll cover from 2023.